Okay, hi class. This is section 14.4. This is the last section for this week, week 7. Okay, now technically, before we do any multiple regression, try to find a multiple regression model in real life, there are certain assumptions that we have to check. Okay, so I have listed these assumptions here, and now I show you how to actually check those assumptions. Okay, one of the assumptions is that this is linear or multiple linear regression. What does that mean? That means your dependent and independent variable should be more or less related with a straight line. Might not be a straight line, but I should be able to fit a pretty good straight line through it. Okay, so how do I test that? Okay, let me get rid of all this. Okay, so this is my original problem. I'm trying to determine if my high school GPA, English placement score, and math placement score can predict my business intelligence program GPA. So the first thing that I would do is to do a scatter diagram, just like the one that I learned in um, Stat 101 or in chapter 13. Okay, so I go ahead and go to taking these two. This is the dependent, this is the independent. Okay, I go to insert and okay, so this more or less shows that maybe I could I could use a line to go through that. Okay, so you see that I can put a line through it. Okay, the relationship might not be that strong. You see the lines are far, the points of observation are far from the line. Okay, so that's one check. The second check is to take the English scores. That's my independent variable and the dependent variable. Okay, so I did math and GPA. Now I do English and GPA. So I go to insert and this one. Okay, so same thing. It seems like if I go here and take a line, okay, it seems like look at that. My coefficient of correlation is a little bit higher, which makes my coefficient of determination is a little bit higher than this one. Okay, but still, if I take a square root of that, coefficient of correlation is not really that high. These points are far away from the line, so maybe these are not exactly connected linearly. Okay, so this was for my math scores, and this was the relationship. I was checking the relationship between the English scores versus my BIGPA. Okay, this was the math scores versus my BIGPA. Okay, and last one, high school GPA and BIGPA, and insert this one. Okay, this one seems to be a little bit better. You see that the points are more compact. So first let me go ahead and do this. This is my high school GPA, high school GPA versus the relationship with BIGPA. Okay, so if I go to my quick layout and pick this one, okay, you see that coefficient of determination is 0.8, so I have a pretty good correlation. The points are pretty close. No wonder at the end I ended up rejecting math and English scores. Remember that? And we just took the high school GPA. Remember that? We just took the high school GPA. Okay, so that's checking to see if in fact there is a linear relationship. Okay, now the next one says the variation in the residuals is the same for both large and small values of y. Okay, this is something which is called homoscedasticity. Okay, when you hear this big word, what is that all about? Okay, if this is my equation of regression, I want all the points of observation to be nice and compact around the points, almost 50% above, 50% below. Okay, then I don't have that homoscedasticity problem. Okay, but sometimes it happens that as x increases, then the observations go like this. Okay, so for small values of x, my line can predict well, but for large values I have an error, a large error. I don't want that. That's called homoscedasticity. That's what homoscedasticity is about. How do I check that? Very easy. Let's go ahead and take this, put it in the next sheet. Okay, now what I need to do is data analysis, regression. I go through this whole thing. Okay, G1 is fine. And now let's see. I would go ahead and click this one and this one. I tell you what happens now. Okay, and okay. Okay, so everything is fine here, except I have a couple of extra plots. These are the plots that I have to check. What do I check and how do I check them? Okay, I basically check around this line of 0. You see there is a line of 0 here, line pointing 0, line pointing 0. I check to see if almost 50% of points are above and below the line, almost 50%. And if there is a pattern, okay, I shouldn't see a pattern. It should all be random. So right now, it doesn't seem to be that much of a homoscedasticity problem. Okay, so as values of x increase, it's not like the value of the error increases. It's not like that. Okay, and let's take a look at this one here. So now this one, it shows me the predicted value of GPA against the residual. So what I do, I take this whole thing, okay, and I go ahead and insert a scatter diagram for this one here. Okay, so this checks my residuals, my errors, against the predicted value along that line of 0. And if almost half and half is above and below the line of 0, then that shows that I don't have this problem here. The error does not increase as x value increases. I have it's pretty much uniform around the line. So if error is high here, it's high here. If it is low here, it's low there. It's not that the error is low here, high there. Then that is very inconsistent. So that's the way we have checked this one, number 1 and number 2. Number 3 is also fairly easy. How do I do number 3? Number 3 says the residuals follow the normal probability distribution. Okay, so I could either take these numbers, the residuals, and make a histogram from it to see if I can make a frequency distribution or a histogram that shows normal, or this is what I could do. I'm getting rid of these because I'm going to bring them up again. Okay, um, I go to data, data analysis, regression. Okay, I'm doing the whole thing. I'm not changing anything. These are these are gonna come back. I don't need that one, or actually I could leave it there. It will override it. And I check this one here, normal probability plot. I get one extra plot. Okay, and it says, can I overwrite? I say yes. Go ahead and overwrite it. Okay, let's see what I got extra. Okay, this is the only thing that I got extra. The rest is what I had before. Okay, this is the one that I check to see if residuals are normally distributed or not. How do I check this? Okay, so if I click on the chart, go to my chart design, okay, and take a line through it, okay. If these points are very compact around the line, then it is normally distributed. But if the points are shooting up or shooting down, or they are not along a line, then it is not normally distributed. So these points should be very close to that line, which it is. You see how close the points are to the line? So that means that this third one, the residual, follow the normal probability plot. Or sometimes in the book, they give you a histogram, and then you have to check the histogram to see if it is normally distributed or not normally distributed. Okay, and we leave the last one for the second part.